Hello everyone and welcome to Precalculus. Today we're going to be doing section 5.5, which is double angle formulas. So the double angle formulas, we're not actually going to take the time to prove how they come into an existence, but you can trust me. And what we are going to do with them is use them to solve equations. So we'll jump right into our first example and you'll see what I mean. So one of the strategies that we use is factoring. But you can't factor because these don't have anything in common. But if you change that sine of 2x to 2 sine of x cosine of x, now you can factor. Don't forget about factoring out first. A lot of people try and jump right into factoring into binomials, but that's great, but not always the best thing to do. In this case, you can take out a 2. You can take out a cosine. And just because you took everything out doesn't mean it's gone. You have to leave a 1 there as a placeholder. And I've taken out the 2 and the cosine, so I'm left with sine. And now I can solve them individually. Either 2 cosine of x is equal to 0, or 1 plus sine of x is equal to 0. Sine of x is equal to -1 by subtracting 1 from both sides. And that happens at 3 pi halves. And don't forget to add your 2 pi n, because every coterminal answer will also be equal to -1. For the 2 cosine, I can divide both sides by 2, and I just get cosine of x is equal to 0. That happens both at pi halves plus 2 pi n and at 3 pi halves plus 2 pi n. So, of course, I already have this answer, so I don't need to write it twice. But also, you may realize that these can be consolidated, and you can do that by writing pi halves just plus pi n, because on the unit circle, here's pi halves, and here's 3 pi halves, and yes, you could go all the way around adding 2 pi each time and keep going back to that answer, but if you just add pi, you'll get to the 3 pi halves. And then when you add another pi, you'll go back up to the pi halves, and you'll still end up getting all the answers. So this is the best answer, but this is totally acceptable. What you don't need to do is box both of the 3 pi halves, because that would be repetitious. Number 2. So now cosine has 3 choices. Unlike sine, where it was really easy to know what we wanted to plug in, I could put 3 different things into this problem. However, since I have another cosine in the problem, the best choice is the one with the cosines in it. So that would be 2 cosine squared x minus 1 plus cosine of x. So as usual, I'm going to factor, but I'm going to change it to descending order first. And remember that if you have any trouble factoring trig functions, you can pretend that this is 2x squared plus x minus 1. And if you can factor that, then you can factor the trig function. So I want a plus there and a minus there. If you refoil that out, you'll see that it works. So now I'm going to use that for my trig. Instead of 2x, I'll do 2 cosine of x. And instead of x again, I'll just do cosine of x. So I have 2 things being multiplied to make 0. One of the 2 things must actually be equal to 0. If it's this factor, that would happen if cosine of x is equal to -1, and that happens at pi plus 2 pi n. This one solves out to be add 1, divide by 2. Cosine of x is equal to 1/2, and that happens at pi thirds plus 2 pi n. And cosine is also positive in quadrant 4, and pi thirds in quadrant 4 is 5 pi thirds, and again plus 2 pi n. None of these answers overlap like last time, so I can just go ahead and put a box around all of them. Number 3. Now I have sine of 2x, which is my favorite because there's only one thing you can do to replace it. I have to replace it with 2 sine x cosine of x. And then another sine of x is being multiplied is equal to cosine of x. So there's a lot of places that people can go wrong on this one. The biggest mistake I see is eliminating the cosine. You don't want to do that. Don't do that, because that also eliminates an answer. Let's say that cosine of x was equal to 0. That would make both sides true. So by just crossing it off, you've essentially eliminated it. Instead, you want to set it equal to 0 and then factor. So again, I'm going to make this 2 sine x cosine of x times sine of x. And then I'm going to subtract cosine of x from both sides. Never eliminate a variable. I am going to take a cosine out of both of them. And when I do this, I'm left with 2 sine times sine, which of course we can write as 2 sine squared, and I'm left with 1. Now normally, you might want to consider changing everything to cosines, but as long as the two factors have different trig functions, that's okay. It's when you have two trig functions in your main problem and you can't factor them separately that you need to consider changing that sine squared to a cosine squared. But I don't need to do that here. So one of the two factors must actually be equal to 0. Cosine is equal to 0 at pi halves plus 2 pi n, and at 3 pi halves plus 2 pi n. And this one, I can add 1 to both sides and then divide by 2. And then I take the square root of both sides, which I simplify, don't forget your plus or minus, the square root of 1 over the square root of 2, which is 1 over the square root of 2. I'm showing you all the steps here to make sure you're following me, because this is your notes, but I wouldn't expect you to show this many steps on your homework. And that's the square root of 2 over 2. And when is sine equal to the square root of 2 over 2? At pi fourths. Now, normally you have to consider which two quadrants the answer is in. But this time, because it's plus or minus, you want all of them at pi fourths plus 2 pi n. And at 3 pi fourths, which is quadrant 2, plus 2 pi n. That's where sine's positive. And then at 5 pi fourths plus 2 pi n, sine is negative square root of 2 over 2. And then at 7 pi fourths plus 2 pi n. It's a lot of answers. And since none of them overlap, you can go ahead and box all of them. Although, if you wanted to consolidate these two, you could write this one as pi halves plus pi n, which would be awesome that you showed that you understood that. Similarly, you could combine these two, which are across from each other. There's 3 pi fourths and there's 7 pi fourths, and write just 3 pi fourths plus pi n. And then you could consolidate these two, pi fourths and 5 pi fourths are across from each other, and write just pi fourths plus pi n. It's not required, but the reason I keep explaining how to do it is because this is the answer you'll see in your book. So the circled answer is what you'll see in your book, and you might wonder, how did they get that? So the red boxed answers are great, but the green circled answers are definitely more concise. So if you want to stop and try the next one on your own, that would be great. But of course, I am going to do it for you. I have 3 choices for cosine, and I have to figure out which one I want to use. Since I have a sine in my problem and not a cosine, I'm going to use this one, 1 minus 2 sine squared. 1 minus 2 sine squared x. That means the same thing as cosine of 2x. Plus sine of x is equal to 0. Now, even though it's a little funny, I'm actually going to move everything to the other side. I have to rewrite it anyway to change it into descending order. So I'm going to put it in descending order and move them all to the other side, because I think it's easier to factor when my first term is positive. Remember that if you have any trouble factoring, factor just with x's. Don't try and jump right into the sine of x if it's hard for you. But assuming that you do get it, it's going to be 2 sine times sine. And my only choices for 1 are 1 and 1. And this one would have to be negative, and this would have to be positive for my inners and my outers to add up to negative sine of x. So this is all equal to 0. So one of these two factors must actually be equal to 0. If it's this one, then sine of x would be equal to 1. And that happens at pi halves plus 2 pi n. And if I solve this one, I subtract 1 and divide by 2. Sine of x is equal to 1/2 in general at pi 6. But since sine of x is equal to negative 1/2, according to forecast, sine is negative if I'm in quadrant 3 or 4. So I'm going to make this 7 pi 6 plus 2 pi n and 11 pi 6 plus 2 pi n. And none of these answers overlap. So I'm just going to go ahead and box all of them. Number 5. So this one is especially difficult because this is the first time we're actually going to go backwards. So when I look at this, I think, oh, it's not equal to 0. So I can't set each individual factor equal to the square root of 3. That only works when it's equal to 0. I don't have a sine squared, so I can't change the sine squared to a cosine and make the whole problem cosines. So super tricky is that sometimes when you see sine times cosine, you can think to yourself, well, can I change that? So I'm going to separate the 4 into a 2 and a 2 and say that I have 2 sine x cosine of x. Oops, square root of 3. And then now I can change this piece to sine of 2x. And you might be thinking, why do I want to do that? We've just been working on getting rid of it. Well, we've gotten rid of it for a purpose. In this case, we got rid of it so we could change the problem to sines. In this case, we got rid of it because it helped us to factor. For this one, it actually helps us to put it back together because it's a single problem. So I can deal with that 2x pretty easily. In case you've forgotten from chapter 4, when you have a double angle, you want to pretend that that double angle, that 2, is not there until the very last second. And I see that I have written 2 again. 3 over 2. So when is sine equal to the square root of 3 over 2? At pi thirds. And then according to my forecast, it's also in quadrant 2. So also 2 pi thirds plus 2 pi n. So like I said, I don't know if you remember this from chapter 4, but what you've actually done, so you're just about to box your answer, and that's when you say, oh no, I've only solved for 2x. So to actually solve for x, you want to divide everything by 2. So I'm just going to change the color so you can see it a little better. Divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. So of course, now people get stuck. They don't know how to divide pi thirds divided by 2. So my recommendation is that you make this into a fraction, and then you keep the top fraction, you change it to multiplication, and you flip the second one, or flip and multiply, and you get pi 6. So this one becomes pi 6 plus pi n. And this one, same thing. I have 2 pi thirds over 2. I think to myself that it's like 2 over 1, and then I flip and multiply. And then I get 2 pi over 6, which is pi thirds, which is really confusing because that's the answer you had from the beginning. So somebody might think, oh, I could have gotten lucky. Yeah, but I'm checking your work, so you're not getting lucky. And therefore, those are my 2 answers. So remember, double angles are dealt with at the very, very last step. Another way that we use double angle formulas, in addition to this one where we actually put it back into sine of 2x to solve, same thing with graphing. We've never graphed a squared. We learned how to deal with left, right, up, down, amplitude, period, but never a squared. But if you look at this equation and think to yourself, oh, I could use the double angle law by factoring out a 2. If you go back and look at the first page of your notes, 2 cosine squared x minus 1 is right here, is the same as cosine of 2x. And that is something that you can graph. So there's this 2 that stays, and then all of this becomes cosine of 2x. So it has an amplitude of 2 because of that. And then it has a period of 2 pi over b, which in this case, b is 2, so it has a period of pi. And there's no left, right, up, down. So I can just do my amplitude and my period. So I'm going to finish by pi because that's my period. So cosine starts at 1, except it has an amplitude of 2. It ends at 2, and it goes down to negative 2. And I'm just going to go ahead and graph all of them because, I mean, like make all my points ahead of time because I feel like I draw it better when I do that. Okay, so there we go. And that would be cosine, or 2 cosine of 2x. It's going a little faster than normal because its period is twice the speed. Okay. All right, so this is like a whole new kind of problem now. So sine of alpha is 3/5. So hopefully your inclination is draw a triangle. So here's my alpha, which would make this 3 over 5. I'm not going to do the whole Pythagorean theorem by now. I hope you realize that this is 4. It's a 3, 4, 5 right triangle. So the question is, if this has a ratio of 3 to 5, what would happen if I doubled alpha? So I had 2 alphas. What would that make this ratio? So you can't just double this. You can't just say, oh, I'll just double it. So now it's 6 over 5. Well, that would be 1 1/5. That would say this side is 6 and this side is 5, which can't be true because this has to be shorter. Think of it as if you were walking across the street. The shortest distance is straight across. If you walked a diagonal, that would take longer. So it's not a 6 and a 5. It's got to be something else. So be really careful that you don't just think that you can double it. When you see this, it means you're going to use a double angle formula. That's the only way to do this problem. So step 1, use formula. So sine of 2 alpha is 2 sine alpha cosine of alpha. Step 2, draw a triangle, which we already did. Step 3, fill in the formula. So sine of alpha is 3 over 5, and cosine of alpha is 4 over 5. I never actually figured out what alpha was. The question is just, if I double the angle, what's the ratio between the opposite and the hypotenuse now? Now remember, some people get this far and then they still can't finish correctly. When you're trying to multiply a fraction by a whole number, change the whole number to a fraction also, and then you can do numerator times numerator and denominator times denominator, which would be 24 over 25, which that does sound right. This is a little smaller than this. So if this is a ratio of 3 to 5, then this becomes 24 to 25, because you can see they're pretty close in length, but this is still going to be bigger. Let's do another one of those. What's going to make 8 a little bit different is that you have 3 choices for cosine of 2x. So I think I told you that your step 1 should be to use the formula. So people always ask me, which one do I choose? Well, you've got 3 choices. The first one listed on your first page, if you go back there, is cosine squared x minus sine squared x. Or you might choose cosine of 2x is equal to 2 cosine squared x minus 1. Or somebody else might choose cosine of 2x is equal to 1 minus 2 sine squared x. All 3 will give you the same answer. Step 2 was to draw your triangle. So I draw my triangle. Cosine is 2 adjacent over hypotenuse, 2 over 3. If you use the Pythagorean theorem, 9 minus 4 is 5. So square root of 5 is my third side. And remember, quadrant 2, this is a really, really hard thing for people to get correct. They miss it all the time. So that's why cosine is negative, because I'm in quadrant 2. But if I go to do sine, I'm going to make it positive, meaning we'll fill one in though. So now step 3 is to fill things in. So cosine is negative 2 over 3 because I'm in quadrant 2 squared. But sine is opposite over hypotenuse, square root of 5 over 3, and it's positive because I'm in quadrant 2. And then if I simplify that, that gives me 4 over 9 minus, so the square root of 5 squared is still just 5, is 5 over 9, which is negative 1 over 9. If I choose this formula, then I'll have 2 cosine is 2 over 3, but it's negative because I'm in quadrant 2, which gives me 2 over, and then this is 4 over 9. In case you've forgotten, when you're multiplying a whole number by a fraction, the easiest thing to do is change the whole number to a fraction so that you can go straight across the top and straight across the bottom. So now I have 8/9 minus 1. Now you're going to have to change that 8/9 minus 1. You're going to have to change that 1 to 9/9. And then 8/9 minus 9/9 is negative 1/9, which is the same answer that we got before. And you could do it a third way, which would be 1 minus 2 times sine. Now we're in quadrant 2, so sine is positive. Square root of 5 over 3. 1 minus 2 times 5/9. I'm multiplying a fraction by a whole number, so I change that to a whole number. 1 minus 10/9. 9/9 minus 10/9, negative 1/9. I got the same answer no matter which way I did it, which was expected. So where do people go wrong? People forget to figure out that the quadrant matters. People can't do their fractions. They get stuck on this multiplying or even on just doing 8/9 minus 1. So sometimes it just comes down to the algebra, even if you understand the precalculus. Okay, last one. So remember that step 1 is to write down the formula. So we haven't done a tangent one yet. Tangent of 2x is equal to 2 tangent of x over 1 minus tangent squared x. Step 2 is to draw the triangle. It's a cotangent, which is adjacent over opposite. It's negative because what quadrant is that? 3 pi halves, which is here, and 2 pi, which is here. So that's their fancy way of saying you're in quadrant 4. So since you're in quadrant 4, tangent is going to be negative, which will be important in filling this out. Step 3 is to fill in all the pieces. So tangent is 1/4. Oh, negative 1/4. We just said that because it's negative, because it's in quadrant 4. And then 1 minus 1/4, negative 1/4 squared. All right, so we did steps 1, 2, and 3. We wrote the formula, we made the triangle, considering the quadrant, and then we filled it in. You've done the precalculus. The rest of this problem is just basic math. I'm not even going to say algebra. And unfortunately, this is where a lot of people get stuck. So let's do it together. So when you're multiplying a whole number by a fraction, change it to a fraction, and now it's negative 2 over 4. When you square, that means negative 1/4 times negative 1/4. So again, straight across the top and straight across the bottom gives me 1/16. When you want to multiply fractions, you go straight across the top and straight across the bottom. But when you want to add or subtract fractions, you need a common denominator. I'm just going to go ahead and reduce that. 16 over 16 minus 1 over 16 is negative 1/2 over 15 over 16. And now that you have a fraction over a fraction, you can flip and multiply or keep, change, flip. So that gives me negative 16 over 30, which reduces to negative 8 over 15. As you can see, the actual trig, not that bad. But the whole rest of the problem, that was some pretty tricky math there. So pay attention to the little details. That's what's going to get you the A. All right, that's it for section 5.5. And that's the end of the chapter. Have a great day.